The third measure of correlation is called as Spearman's rank correlation. See, if the values are given in ranks instead of the values, like in Carl Pearson's, we have seen that some of the values will be given to us. So immediately we use the formula of Carl Pearson's to find out the answer. But in some cases, instead of giving some arbitrary values, we will be given ranks. In such cases, we have a concept which is called as Spearman's rank correlation to find out the answer. Now, the formula of Spearman's rank correlation coefficient is denoted by RS, or it is also denoted by a symbol which is called as rho. It is also called as a rho. Rho is equal to 1 minus 6 summation d square by n into n square minus 1 is our formula. There n is number of pairs of observations, number of observations which are given in the problem. So once n value, once let us suppose 10 observations are given to us, then immediately we can find out the denominator, that is 10 into 10 square minus 1. Anyways, this is 1 minus 6 and summation d square. The only value which we need to find out is called as summation d square. Summation d square means first we need to find out d square, then immediately we can find out summation of that particular column. So first of all, to find out d, we have to know what do you mean by d here. Let's take an example of the problem, then let's discuss what do you mean by that. See, how do you identify? For suppose there was a question given to us, but it was not mentioned which method has to be followed. Then we ourselves has to identify whether the problem belongs to the rank correlation or a normal Carl Pearson's coefficient of correlation. See, we will be given some numbers in the table format that, see, all these numbers already started from 1, and since there are 15 observations, it is ended at 15. In the second row also, the numbers are up to 15 starting from 1. There is no, see, the numbers have been jumbled, but there is no deviation in the sequence of the numbers. Identification of the problem is that if the numbers are starting from 1, why? Because rank always starts from 1, right? Rank number 1, 2, 3, 4, 5 up to 15. So if some ranks are given, we can solve the problem by using Spearman's rank correlation coefficient. If not, either we have a formula to find out Carl Pearson's coefficient of correlation or scatter diagram method also. Now let us take in this example, what they are asking us to find out. Let's see into that. Okay, the ranks of same 15 students into subjects A and B are given below. Use Spearman's formula to find out rank correlation coefficient. What they are saying that here there are 15 students are there, and they were given a test on two subjects A and B. So the first person got rank in subject A and 10th rank in subject B. Okay, and the second person got second rank in subject A, but he got 7th rank in subject B. Similarly, the third person has got third rank in subject A, but second rank in subject B. So, based on this particular data, based upon this data, he is asking us to find out what type of relation is there between the subjects A and B. That means whether subject, that means if a student get more marks in subject A, as well he will get the more marks in subject B. That means whether there is a positive relation between subject A and B or a negative correlation. Okay, let's take an example of two subjects, mathematics and statistics. Both are practical subjects only, where you have the same different kind of formulas. If you are very good at maths, that means very good at calculation, you get both good marks in mathematics as well in statistics. That means the subjects maths and statistics are positively related. Sometimes we do not say that every time it is related, because it is depend upon the performance of the students here. So similarly, let us find out whether there is a relation of positive relation or a negative relation between subjects A and B. So to find out that, let us use this tabular form here. First one. See, in our formula, I already told you that we need to find out d square. Summation d square is d square. So what do you mean by d here? D is nothing but difference of ranks. Difference of ranks. Here we were given two subjects, subject A and subject B. Now here D can be taken as ranks of A minus ranks of B or ranks of B minus ranks of A. However you take it, both are correct. There is no rule that always you have to take the RA minus RB. See, the notation of R suffix A is nothing but ranks of subject A and RB is ranks of subject B. So now let us find out the difference that now 1 minus 10 is minus 9. Likewise, see 2 minus 7 is minus 5, 3 minus 2, 1, 4 minus 6 minus 2, 5 minus 4 is 1, 6 minus 8 minus 2, 7 minus 3, 4. Likewise, we have all these answers, that is D. Simply, next immediately squaring these values, what is the answers we get? 9 nines are 9 square, minus into minus gets plus, right? So 9 nines are 81 and 5 square 25, 1, 4, 1, 4, 16, 7 sevens are 49, next 4, 25, 4, next one is 7 sevens are 49, 1 square is 1, 2 square 4, 2 square is also 4. So immediately what it is directly as happening here, see one sum are the sum as, that means summation is value as 2 value. I have found out the column additions over here. Now simply substitute these values, into our, then so substituting in our formula, what is that we get here? 1 minus 6 into summation D square. What is summation D square? 272. 6 into 272 divided by, we have n is how many number of observations are there? We have 15 observations. 15 into 15 square minus 1. So this is our expression. So finding out the answer of this one, so we get 1 minus. So here the calculation, let us do the calculation part. Now 6 into 272, the answer is 1632, 1632. 1632 divided by 15 into 15 square minus 1. So to find out, first of all, let us have this one. 15 square is 225 minus 1. Okay. Then is equal to 1 minus 1632 divided by, here 225 minus 1 is 224. So 224 into 15. Answer is 3360. That
0.52.
3360. So is equal to 1 minus 1632 divided by 3360. Let's find out the answer. 1632 divided by 3360. Just a minute. We got the answer as 0.4857. 0.4857. That means 1 minus 0.4857, we get the answer as, see here, minus 1 is equal to 0.5142. 0.5142 is our answer. Now, what is the value of R here? It is 0.5. 0.5 means what? It is greater than 0 but less than 1. According to our rule, if R value is greater than 0, then the two variables are positively correlated. That means the subjects A and B, both are positively correlated. That means here we have to write down the conclusion that not subjects are related. Subjects are, we cannot decide that the subjects are related. We have to decide on the student's performance over here. That means if the student get more marks in A, as well he get very good marks in B also. That means if the student is, see here 39-14 means what? He is the least ranker. He is the least ranker in both subject A and B. Here 14th person and 15th person are also same. But see here, the person who got number third rank is getting second rank. That means almost the positions in their classroom, according to the subjects, are very nearby. Only one or two values are more deviated. See here, 1, 10, 8, 1, 12, 5. These are the only three observations which are mostly deviated. But finally, we have, see, if those numbers are also nearby, then our correlation value will be either 0.8 or 0.9. Due to these deviations in the problem, I have got the answer as 0.5. Anyways, the student's performance, if he is getting more marks in subject A, he'll get more marks in subject B also. That is the conclusion of the problem.